Okay, so areas between two curves. I just quickly did it. So last lesson we were kind of filling in the table. Yeah. Yeah, some of you might just want to check the last line. So what we're doing, as Tilly's mentioned, we were calculating the areas of each of these rectangles. So remember, shh, thank you. So we're on page 27. Shh, Lauren. Okay. So the areas between two curves, guys, come on, let's go. So areas between two curves, what we're doing is we're breaking the area into 5 different rectangles. We worked out that the width of them is all just 1, and we've worked out the height of them by doing this point, this y coordinate minus that y coordinate, this y coordinate minus that one, this y coordinate minus that one is how we got the heights. And then the areas of each rectangle, of course, are going to be length times width, base times height. Yep, base times height or length times width. So that's what we did there. We subbed in the midpoints of each one. We subbed in the midpoints of each category, and got the widths were all 1. These were all the respective heights of each of them. Notice that each rectangle was getting bigger from left to right, so that's why the numbers are getting bigger from left to right. And then length times width to get these ones. This one says f of 3 minus g of 3 equals 18 minus 7, because that's the height minus the bottom height, is 17. 18 minus 1 is 17, sorry. 17 times 1 is 17. So we individually calculated each separate little area. On the next page, we're asked to approximate the area between the curves by finding the sum of the areas of the rectangles. So we're going to try to approximate, come up with a rough idea of what this whole green area is in roughly by adding those together. I'll move this one out of the way. So approximate the area between the curves by finding the sum of the areas of the rectangles. How would I show working out? This was an exam question for some reason.
What did you say for some reason?
Yeah, it's a weird one. 1 plus.
Oh, I have that. 2 plus 5.
Where'd you get these numbers from, Kate?
The areas from the last column.
Oh, just adding those up? Okay.
These are like, because there was 5 rectangles, and so to find the overall area, 35. I don't know. If we had to show units, what could we write?
Units.
Square.
Square.
Units, or square units, that kind of thing.
That is an issue.
So they've told us roughly, because notice the topic is about areas between two curves. So what we've done is we've vaguely, by hand, worked out the area between two curves. We've vaguely done it by hand. So what we're asked to now do is write down a definite integral you think can be used to find the exact area between the two curves, like x squared plus 3x, the quadratic, and x minus 2, the linear, between x is -5 and 3.5. What they're asking is, how do you want to guess that we might set up a definite integral to work out the areas between these two?
Oh, you got a point.
Yeah, so we need to write, what's the funny symbol we need to write?
Integrate.
Yes, the twig, yeah. That's right, the twig, or remember it's an elongated S, standing for sums, because it's all about the sums of the rectangles underneath the curve. Remember Leibniz, he came up with this symbol. It's an elongated S, standing for sum, because in theory, integration is about like adding up the areas of rectangles underneath. But as the number of rectangles approaches infinity, kind of, you get closer and closer to the real area between the two, or the real area under the curve. So it comes from an elongated S. What would be our lower limit according to this question? Yep, -1.5. Yep. So, what? Bella, why is it -1.5?
Because it's the, wait, what do you mean? Why is it? Oh, you mean why it's there?
Yeah.
It's the lower bit.
The lower bit, yeah. And what would be the upper limit? 3.5. Well done, everyone. That's between -1.5 and 3.5. Now, what's interesting is how did we work out the height? Let's have a look at the picture again. How did we work out this height? How did we work out the height of that rectangle again? The midpoint. And what did we do with x? Yeah, good. We worked out that one, f of x, the red one. So the height there minus g of x.
Okay.
So we kind of did f of x, and for each of those, notice to get this height, we did like Sarah said.
Yeah, on this chart we did the f of x, subtract the g of x to find the height right here.
Yeah. What do you notice about why did we do the f of x first? And it's just a really easy reason.
Because it's the higher one.
It's a higher one. So notice we do the higher one first, minus the lower one.
That's four well.
So using that kind of logic, so you could to start with write f of x minus g of x, or you could just go straight to writing these two things and subtracting.
So we're finding the. Okay.
Yeah, how could you write it as an integral? So we'd have to do a big bracket to start with, and then within there maybe write x squared plus 3x, and then it's always minus the other thing.
So it's in square brackets?
Yeah, or just a bigger bracket overall, because you remember like we've got to put something dx at the end. So I've got the big bracket just because we've got to write dx at the end kind of thing. And then minus the other thing, the lower one. Good. Yep, that's exactly it.
I'm not quite sure why we're
And
doing
then
it.
close that dx. So notice what we did was, it's the integral between the lower bound and the upper bound.
Mm-hmm.
And it's the higher function, so this is the higher function, minus the lower down function.
And that gives us the area?
Yeah, that's going to, when we actually calculate this in our calculator, and the next step, you might find it's something pretty close to what we just did here.
So in the brackets, when we subtract them, what does that give us? Like in the table when we did that, what did that give us? What were those values? What did
Oh, it gave you the height of the rectangle.
So we're using the height to figure out the area. We're integrating the height to figure out the area. Because that will give us the height, right? Subtracting them.
Oh, yeah, because f of x is the height at each x value. Yeah.
So we're integrating the height, that'll give us the area.
Yeah. So this is what would you call it, the higher sitting function? How would you describe the one that sits
Upper
higher?
bound.
Oh, no, not upper bound, but these are two functions. That's a parabola, and that's a linear. The top
function.
Top function, yeah. That's the top function. Sits on the top. And this one's the bottom function. This is actually important. It's because when we do practice problems, identifying which one is the top function, putting it first, and which one's the bottom function, putting it second, is actually really important. So just trying to point out in case anyone didn't get it, the top function is the parabola because it's up higher. The bottom function is the linear. Sorry about that. So then what we're going to do is, I'll give you a chance to write that. We're going to, calculate. That says bottom function.
Calculate, like, it's something like calculator.
And then we're going to pop this into our thingamajiggy. And we're going to, and you'll probably see we get something close to 35, not exactly 35, because the thing we did was a rough approximation because we only used 5 rectangles. But in theory, it should be like loads and loads and loads and loads of like almost an infinite amount of rectangles.
Why is this even necessary to solve this?
And the calculator itself is only an approximation too. Yeah.
What would be an example of like a real situation where you have to use this?
Did you see here in the videos when Grace said, "What is this all for?"
What's the point of this?
Listen to them on mute.
I didn't do that.
I got all the good comments.
No, I don't say it. I mute it and I play
might
music.
put it on like high speed.
I'm supposed to be. I'm shattered.
Nanny, what's the point of this? Like her face was so blank, and she was just like, "What's the point of this?" And it was just so funny.
And then we started Googling like what integrals are used for. I can actually even say my boyfriend uses them in his work because he's an actuary and he has to integrate to find models. He has to do integration and calculate probabilities. And he kind of uses spreadsheets to do it, but he needs to know what the theory behind it is.
Where does he work?
At Hanover. Hanover.
That sounds familiar.
Yeah, but that's an example. So if you want to work in finance in Bermuda, you could end up using this a fair bit. Yeah. So if you do want to work in finance in Bermuda, like in the reinsurance industry, like integration is actually something that's one of the fields that you would actually use it. He does modeling and he does have to use integrals. But as I said, he uses spreadsheets to calculate them. But he needs to know the math behind it, kind of.
Got it. Can I give you my calculator so challenge? I got 35.41.
Oh God, I got it too.
Good job.
How do you do it, by the way, in case anyone's forgotten?
Math 9.
Math 9. Yep, and you put in all this stuff. Be very careful. When I did it, I messed up my double brackets. I forgot to have a second bracket here and a little bracket. To be honest, I didn't really need a bracket in the green ones, but if I didn't have a bracket in girls, if I didn't have a bracket in the blue one, why is it a problem for Bella?
Megan making my positive.
Because
Yeah.
it won't work.
Yeah, because if I didn't have a bracket here, then it would have just done negative x minus 2, but really it's negative x plus 2, yeah, exactly. So the bracket on the second one, if it's two terms together, added together, it's really
I'm
important.
gonna do
The first one, to be honest, isn't a bigger deal. If you want to cut out some brackets, you don't really need them in the first one. But you do need them in the second one if there's more than a term kind of added together. So Sarah's answer was correct. What did you get, Sarah?
I got.
Excuse me.
Krista can go because she got it before.
No, I said it and Miss Maloney ignored me.
Oh, did I?
Yes!
Okay, well, it says integrate function or something. And then, yeah, what was it? Sorry, Krista.
No, Sarah can say I'm doing my problem.
What is it as an exact answer, do you think?
35.41666667.
What do you mean, do you?
Oh, and what the calculator's done is it's actually for
So it's
1
6
6
recurring.
recurring. Yeah. Yeah, because the calculator just rounded the final digits. That's all.
LNTFN.
Then you don't put
Math 9. Oh, it's meant to be function integrate, sorry. It's 9 FNINT.
It's int fun.
Is it?
I
forget what you mean.
I'm saying that's what
It's a 9. Is it FNINT, isn't it? Sorry. That's the buttons you press. And then you plug in all this stuff.
I did it without the brackets and I got a different answer.
Holy
No, I
moly.
did it on purpose
Oh.
to see what the answer would be.
Oh, okay, yeah, because in theory, then instead of +2, they'll have -2, wouldn't they? Yeah. So it says compare, guys, thanks. Compare your answer to the approximation from question 2. Are they pretty similar?
We forgot the integral on our GDC. Oh, never mind.
Yeah, they are very similar. 35, and you can write 35.416. We're at 416 recurring. Very similar. You might say 35 was just a very rough approximation using only 5 rectangles. Very rough approximation. Sorry, get out of the way soon. Using only 5 rectangles. Whereas what the calculator's doing is it's using a lot more rectangles. Like, it's impossible to use an infinite amount of rectangles on the calculator, so they just use a lot of rectangles. So the calculator's sometimes slightly off as well, but it's more accurate than what we did by hand. What was that, sorry, Krista?
Oh, I don't remember.
That's right. So they're very similar. 35 was just a rough approximation, but what the calculator's doing is they're doing it using like way more rectangles than 5. So that's why they're a lot more accurate. In theory kind of approach.
Is that coffee?
Nah, it's tea. Gotta have a break from coffee. Radical. Sorry, some people are writing some stuff. Okay, so we're on to, that was 28, cool. So we're on to 29. So 29, we're just formally stating what we've just learnt from the investigation. And then we do an example on the back page.
Hey, Miss Maloney. What about 6?
Big questions today. Big questions in life.
Because, like, you're a teacher. So would you want to have kids?
Do you find some teachers don't have them?
Yeah.
Isn't that funny?
I think
It's a bit of a weird thing,
so,
actually, isn't it? Yeah. Maybe sometimes I wonder that. Like, I wonder if like we don't get the big biological urge as much because we're around kids all the time. So our body's tricked into thinking we have hundreds of kids.
I don't think that's a statement.
Because we're around them all day. Whereas other people in other workplaces don't really interact with the next generation at all. So they probably have this biological need to.
Okay, so you don't.
That's my theory. So our body thinks we've had hundreds of them.
You don't like think like, kids, I need them. You know what I mean?
I wouldn't mind having dogs.
Dog.
Yeah, I like a dog.
Hey, you wouldn't mind having a dog?
Yes.
I don't mind. I could go either way. I could go either way.
You're a child. It doesn't matter.
I know a dog definitely. But like the kid, I could go either way. I could go either way.
But one is definitely more expensive.
That's true.
Pet insurance. Your dog has diseases.
Okay, you want to send your dog to be insured?
Such a bizarre thought.
I wouldn't mind having a dog.
Oh no, I know. They're nice. But but yeah, I don't know. Same as my siblings. 2 have had them and 2 haven't. And so that's why. Yeah, I have 4 older siblings, and 2 had them. A boy and a girl had them, and a guy and a girl didn't. So that's why I'm the one that could tip the balance. And they're still kind of like, what's going to happen?
Interesting. So you feel like it's enough for you, so
Yeah.
you stop being a little.
Yeah, that's true. And also, like, means at Christmas time, you have the big Christmases, and there's kids there and stuff. That kind of thing is quite nice. Mind you, some of them are getting old enough to have their own. The oldest one's like about 22, but the youngest one's still in primary.
Yeah, my nieces and nephews make me not want to have kids, but.
Yeah, and some people just know from an early age. Some people are kind of on the fence and see what happens.
She's so rude. We went to this math class. It was Dallas. My friend.
So you had to go to the ceremony, the naming ceremony.
Wait,
Okay, remember this is recording. Okay, so from the investigation, this is pages just formalising what we just said, so it's not too intense. So how would you say in formal words? So from the investigation on the previous page, we can assume that if y1 and y2 are continuous, what does that mean? Yeah, there's no breaks in them or that kind of thing, like they're not broken up, they're not crossing over. So continuous, like basically not broken up. I think not crossing either, not broken up or crossing over or something like that. So if y1 and y2 are continuous on, what do you think A and B are? It's meant to be obvious that way, it's not a trick.
A and B.
Lower and upper limit. Yeah, the lower and upper limit, like A and B, in terms of the x value. So if y1 and y2 are continuous on the interval A to B, so from A to B basically, and y1, what do you think this bit means? Yeah, in terms of the 2 functions. It was something.
For a while.
It's something to do with what we were saying on the previous page.
You said that
So why do
no one's listening.
Bella? I'm poor Bella. You're my go-to. You're my go-to one to pick on. Owen's been through the ringer. Now it's Bella's turn. Lauren did for a bit. And then so why so you're right, Bella. Y1 is greater than or equal to Y2. What do you think they're meaning about the location? Yeah, further up, yeah. So they're saying the Y1, yeah, good. Y1 would be the top function. So meaning Y1 sits above. So what?
Oh.
Okay. Oh, now it's completely off. So basically what I'm trying to write here is Y1 sits above Y2. That's what that thing means. Y1 sits above Y2. Okay, so Y1 sits above Y2. So see, it's happening again.
Maybe because it's just
But it's also, it is warm in here too.
You turned it off when you got cool, and now you're getting hot, so you're turning it back on.
Okay, so what that means there is y1 sits above y2. So what it says, if y1 and y2 are continuous on that interval, and y1 sits above y2 for all x in that interval, then the area between y1 and y2 from between x equals a and x equals to b can be given by,
Oh, you just see it, isn't it?
yeah, and then what we do is the general way they say it is the integral y1 minus y2 yes, and you've got to have your little I forgot to put in the a and b on my limits actually when I did my notes.
Y2 subtract Y1 because Y2 is usually bigger than Y1.
Is this a formula that we need to memorize?
Hang on.
It's better than
Oh, that was bad. So see, I just put my there need to be the limits a and b. I just didn't write properly.
Does A always have to be at the bottom?
The lower. So what's interesting? Lower on the bottom to me, and upper on the top.
Why is it
Yeah. So
Is this
yeah. See, a is lower. A is B.
or no?
That's a good point.
Because French
Gonna have
is
a look.
accent.
Sarah's just gonna have a look on that front page.
Sorry.
I do not see.
She listens to Sarah and that's it.
I can have a quick look at the front page.
Right away.
Can I run to the washroom?
Alright.
Thank you.
Oh, yes, it's Eddie. See, Calvin is
Why don't you?
So Calvin is
Yeah, we don't wash it. We don't rest it. We don't rest it. We don't bathe it.
Okay, would you walk it?
You
No,
know
they don't
what?
have it yet. They don't have it.
So that's your general thing.
I said that.
So this is the general thing. So you're all cool. Okay.
I like it. Look at you.
It's very, it's the first shot out.
There it is. So that's what it is in general.
Yeah. It's nice.
Do you hear this is yes, we're learning maths. Oh gosh, look, I can move it. Nice. There you go. So it's meant to sit more there. Isn't good? They're good.
Don't you think?
It is a bit. Yeah, exactly. It is a little bit cold now.
And no one else is a little cold?
Yeah, some people might want a bit more. Okay, so it's probably going here over here. Okay, so thank you. So see, that was a very fancy way of saying, basically you take the top function, this has to be the top function, minus the bottom function. Feel free if you want to make an extra note. That has to be the top function and that has to be the bottom function.
You should always.
Y2 is the bottom one.
Yeah, y2 is the bottom one. So it's always the top function minus the bottom function, basically.
Top funk minus bottom funk.
Yeah, you might want to make a note of that. Top function is a y1, bottom function is the y2. And for the sake of people who don't listen to the audio, maybe I'll put you guys down. So that's the top function. You missed out on all
We
our
all do
gags.
that. I understand.
All our gags till he's...
I see them when they're more funny when I'm there.
Do you know what you can do is, you can put CC, you can put subtitles on. So they'll be kind of
Like
like...
subtitles on YouTube are always wrong.
But they're so funny. They're so funny.
About like some weird stuff that has nothing to do with what you're doing.
You would say the number 8 and they would say ATE. Like they're just wrong.
So what I've said is now write the above statement in your own words. So like you can write it in whatever words make sense to you.
It's total. No, it ain't.
So some people might make point of what's important. Y1 sits higher up than Y2.
It's total.
So whatever big things you took away from that. What's another thing, Bella, we can write? So one thing that you can take away. Y1 sits higher up than Y2. Anything else?
The top function minus the bottom function.
Yeah. Yeah. I use the lower. Did I? This part about it. I don't know, I kind of feel like we said that about there, but like maybe it wasn't clear. You can write it, you would have, you write whatever you think you want to take away from it. If you want to write that, Bella, you go ahead and you write that. So you subtract the lower from the higher, that kind of thing. Oh, don't forget then, you then integrate the result. Integrate the result. You then integrate the result. So whatever you want to take away from it, I wrote all sorts of waffly stuff, but I think you've kind of picked it up by now. I don't think we need to write it. And why they say them being continuous, notice there's no breaks in the function and they're not really crossing over each other at this point.
There's no wobbling for anybody?
You know, it says that they're continuous. Yeah, there's no breaks in the function. Like it doesn't break up. It's a long continuous function.
Okay.
And the functions don't seem to cross over each other. The main thing is that there's no breaks in the function.
So they
What's
do
called
cross
now?
over, they don't cross over.
Nah, they don't. This, in general.
I'm not gonna turn it off, just gonna turn it up a bit.
Whole page is going to get sick. Okay, anyone still writing? Okay. So here I said rewrite the statement in relation to the graph pictured here. So rather than write a big horrible sentence, which one is Y1? The pink one or the
Pink, purple, the B is red.
Which one is Y1? Yeah, that's right. That's Y1. Which one is? So that one's obviously Y2. So it's important you've got to have the top function minus the bottom function. So we've got to do the elongated S. Oh gosh. We don't know what the lower bound is or the upper bound is yet. Yeah, let's do A and B for now.
Where's the lower one?
B will be down here somewhere. And we're going to calculate. So out of interest, how can we find what A and B are? Like it's something you would have done in basic.
It's where they cross.
Yeah, the intersection points.
Wait, so why did you choose B?
So
Is B not 4?
So see the whole, see the area here compared with the area. The area begins there and ends there.
That's
yeah.
where it colored.
Yeah. So it might end up being 4, but you don't know. It could be 3.9 or it could be 4.1.
Oh, come on.
So we're going to calculate it exactly to be on the safe side. So it could be 4 if you just had a vague look at it, but we're just going to calculate to be on the safe side. So BA, don't forget it's the big area. So do your big bracket. It's the big area, the top area, 5x minus x squared minus, and it's just x, so feel free not to put it in another bracket if you don't want, dx.
DX? My God.
Is that the only one listening to that?
They don't say not the scale.
You have to assume that it's not.
Every time you're in a class, it's not scale, right? Not to scale. It's correct with that. It says like small, right?
Oh, you meant to
You have like a triangle right here. It's like not to scale.
So we're going to do this one on a calculator. So to find A and B, so we're going to do this non-calculator. So to find A and B, how would we? So to find A and B,
Would be.
just listen. What's that? Sorry.
And put a number into X.
You could. Remember at those intersection points.
Oh, you make them equal.
They're equal to each other. Yeah, so set them equal to each other and solve for x.
Oh, they could.
Yeah. That's right. At these little points of intersection, well done, they're equal to each other. To find A and B, set the two functions equal to each other and solve for x. Set the two functions equal to each other. To each other. And solve for x. So I kind of do that on the side. It's up to you where you want to do it. And then I do the main integrating bit over here. So I kind of do this as a little side thought. So our two functions are 5x minus x squared and x.
Bless you, Owen.
So 5x. Oh no, and there's a lot of sick people too. Okay, so see how we set the top function equal to the bottom one, doesn't matter here because you just set them equal to each other. And now we solve for x. Yeah.
Are we gonna be doing a lot of work in over here, and that's gonna work in over here?
Yeah, like we're just here to find what A and B are. And then we're going to use it over here and calculate by hand the integral.
up here with that one's done.
Yeah, we're kind of done. I kind of wrote a big awkward explanation, but I can't be bothered doing that now. You seem to get it now.
This works out because you can't find the square root of a negative number.
So then you end up with 0 equals x plus x squared minus 5x. So did you get 0 equals x squared minus 4x? I'll just go down so you can see that.
I got x equals.
And then did you get something like that?
No, I didn't do any of that.
And the only reason I brought them over to the same side is I noticed it's becoming a quadratic that we can solve. Because notice there's 2 intersection points, so we're going to get a quadratic that we can factorize and solve.
This is wrong, but this is just right.
4 is one of them. So I'll just show you that. Okay, so because I noticed that there's 2, I thought, okay, let's turn it into a quadratic, so get it all on one side. Set it equal to 0 and solve. So how would you solve this? How would you factorize that quadratic?
X.
Yeah, good. Take that common factor. Okay. Good that you're thinking about that stuff, because it's been a while. Yep, let's just take out x as a common factor. So then our two answers are x equals 0 and x equals 4, yeah? So A must be the one on the left.
So it was 4.
That's right, and B
We knew
is
that.
4, you're right.
We knew that.
So this stuff on the side was just for the purpose of working out what A and B is. So let's rewrite that integral. So let's put in our 0 and 4.
You know what's dumb about factoring? We make both of those terms equal to 0, but really only one needs to be 0 for the base to equal 0.
And what is because we're doing this one by hand, it might be easier to simplify this. So what's 5x minus x squared minus x? Can it simplify
4x.
it? Yep.
Subtract x squared.
Yep, that's right. 4x, because of this, subtract x squared. So that might just make life easier, because that does combine to give you 4x minus x squared, and I'll scroll down. And then we'll do this one non-calc.
Non-calculus for having?
Yeah.
Oh, this is my
And
favorite.
then the dx. So now we've got to integrate both thingies, and I can just start to put things into those.
Oh.
Lauren, are you thirsty?
Okay. Rightio, cool. Okay, so when we integrate,
She's okay.
what does 4x become to start with? It'll be 4x.
4x squared over 2.
Yep.
Minus x cubed.
Why did you do the over integrate? What? No.
Yeah.
Yes.
Oh, yeah, yeah.
Yes.
And then don't forget your 4 and 0 out here.
Wait, no.
And then I would suggest before you you could calculate it like that, but for me, I'm going to find it easy to simplify this term on the left. That's gonna
Wait,
make my life easier.
Oh yeah, you're smart, Miss May.
Why is it
Just
over
makes life
2?
easier. Oh, because the new exponent is 2, and so you always divide by the new exponent. And then 4x squared over 2.
I
2x squared.
Wouldn't Miss Melanie,
That's good.
how did you get 4x subtract x squared when on that side it says x squared subtract 4x?
It's the same thing. It's just that she rearranged it differently, but it's basically the same thing.
See that thing, yeah.
Doesn't matter. Okay.
Yeah. Yeah, this stuff on the side was just for the purpose of working out. This was just for the purpose of working out A and B. That's what that side stuff was. And now what I'm doing is, that's why I left this stuff for this side, I'm continuing this thing down here. So if you want, feel free to draw an arrow. And then 5x minus x became 4x down there. And then we kind of feel free to work stuff out. And we'll see what we get. That one. No!
Yeah.
And then did you get 2, 4
4
squared
times 4 is 16 times 4
minus
is
4 cubed over 3?
64.
Sorry about the notation. Minus 2, 0 squared minus 0 cubed over 3. Obviously it's minus 0. So we've got to work out that bit on the left, and that's it. And I'll cut it. What did you get? Did you get 64 for that?
Yeah, that's what Grace just said.
Oh, I don't know.
Negative
I made up a
32
number.
Yeah, 16 times 2.
Yeah.
Because remember, Ben,
32.
I left
16
it in
times
the
2, yeah, 16 times 2, yeah, good, is 32 minus, what's 4 cubed? 64 over 3,
I was right.
and then minus 0. And then,
I didn't know you, bro.
and then, well, if you could do, you can work out 64 over 3 first, or you can write 32 as 96 over 3,
I forgot about the other 3 you did.
64 over 3. So what's 96 over 3 minus 64 over 3?
Oh!
Ooh.
I'm doing semi-long.
32.
Yeah, 32 over 3. So 32 over 3 is totally okay as an answer.
And then negative.
You could also write 10 and 2/3. Or you could write 10.6 recurrent. And square units if you want. And you could put square units or units squared if you want to write anything. The next ones we're going to do on the next pages will be with calculator. So don't forget, of course, you always remember your calculator.
This.
Adapter. What are you talking about?
What's in front of you?
I lose.